Download this code from codegive.com, link in the description below. Spring Boot Asynchronous Processing with Async, Part 1, threadpooltaskexecutor. This tutorial delves into Spring Boot's asynchronous processing capabilities using the @async annotation and focuses specifically on configuring and using threadpooltaskexecutor for managing asynchronous tasks. Why asynchronous processing? In modern application development, responsiveness and scalability are crucial. Synchronous operations, where a thread waits for a task to complete before proceeding, can lead to performance bottlenecks and a poor user experience, especially for long-running or resource-intensive tasks. Asynchronous processing addresses this by allowing the main application thread to continue executing while offloading slower tasks to background threads. This improves overall application responsiveness and can significantly enhance throughput. Spring's @async annotation, a simple entry point. Spring's @async annotation provides a straightforward way to declare a method as asynchronous. When a method is annotated with @async, Spring intercepts the call and executes it in a separate thread, allowing the caller to continue execution without blocking. The role of threadpooltaskexecutor. While @async simplifies asynchronous method invocation, you need a mechanism to manage the execution of these asynchronous tasks. This is where threadpooltaskexecutor comes in. It's a Spring-provided task executor implementation that uses a thread pool to efficiently manage and execute asynchronous tasks. Thread pools offer several advantages. Resource management. Thread creation and destruction are expensive operations. Thread pools reuse existing threads, reducing overhead and improving performance. Concurrency control. Thread pools limit the number of concurrently running threads, preventing resource exhaustion and potential system instability. Queuing. When the thread pool is at its maximum capacity, incoming tasks can be queued, ensuring that they are eventually processed. Tutorial outline. This part 1 of the tutorial will cover 1. Project setup. Creating a basic Spring Boot project. 2. Enabling asynchronous processing. Configuring @enable async. 3. Creating a simple asynchronous method. Using @async on a basic method. 4. Configuring threadpooltaskexecutor. Creating and customizing a threadpooltaskexecutor bean. 5. Understanding key threadpooltaskexecutor properties. Core pool size, max pool size, queue capacity, thread name prefix. 6. Exception handling in asynchronous methods. Dealing with exceptions thrown within @async methods. Let's begin. 1. Project setup, Spring initializer. Navigate to https://start.spring.io/ https://start.spring.io. Configure the project. Project Maven or Gradle, your preference. Language Java. Spring Boot choose the latest stable version, example 3.2.x. Group com example. Artifact async demo. Packaging jar. Java version 17, or later. Dependencies Spring Web. Click Generate. Download the zip file and extract it. 2. Enabling asynchronous processing ***. In your src/main/java/com/example/async demo application.java or the equivalent application entry point, add the @enable async annotation to the main application class. @enable async tells Spring to look for methods annotated with @async and to process them asynchronously. It essentially enables the infrastructure needed to support asynchronous execution. 3. Creating a simple asynchronous method ***. Create a new class, example async service.java, within the com example.async demo package. Explanation ***. At service marks this class as a Spring service component, making it eligible for dependency injection. At async, this is the core annotation. It indicates that the perform async task method should be executed asynchronously. When this method is called, Spring will intercept the call and submit the task to a task executor for execution in a separate thread. *thread.sleep, 5000, this simulates a task that takes 5 seconds to complete, allowing us to observe the asynchronous behavior. Important * in a real-world application, you would replace this with actual, potentially blocking, logic. *logger, we use a logger to track the start and completion of the task and the thread in which it's executed. This will help us verify that the task is running asynchronously. 4. Creating a controller to trigger the asynchronous task ***. Create a controller class, example async controller.java, to trigger the asynchronous task. Explanation ***. At REST controller, marks this class as a Spring REST controller. At auto-wired, injects the async service instance into the controller. At get mapping, /start task, maps the /start task endpoint to the start async task method. Async service.perform async task, sample task, calls the asynchronous method in the async service. Notice that the controller method doesn't wait for the asynchronous task to complete. The logger statements show the thread name before and after calling the asynchronous method, demonstrating that the controller continues to execute while the asynchronous task runs in the background. 5. Running the application, first run, default thread pool. Run your Spring Boot application. Access the /start task endpoint in your browser or using a tool like curl or Postman. Observation, without custom threadpooltaskexecutor. Examine the logs. You should see something like this. The controller method, start async task, runs in the HTTP Neo 8080 exec1 thread, or similar, depending on your server configuration. The asynchronous task, perform async task, runs in a thread named taskexecutor1. This shows that Spring is using its default simple async task executor, which creates a new thread for each task when no task executor bean is defined. This is not a thread pool and is generally not suitable for production environments because of the overhead of creating threads for each task. 6. Configuring threadpooltaskexecutor ***. Now, let's create and configure a threadpooltaskexecutor bean. Create a configuration class, example async config.java, within the com example.async demo package. Explanation ***. At configuration, marks this class as a Spring configuration class. At bean, name equals task executor, defines a bean of type executor named task executor. This is crucial. Spring will now use this bean as the task executor for async methods. If you don't explicitly specify a bean name, Spring will try to use a bean named task executor by default. Threadpooltaskexecutor creates an instance of threadpooltaskexecutor. Executor.set core pool size, 2, sets the core pool size to 2. This means the thread pool will initially maintain 2 active threads, even if they are idle. Executor.set max pool size, 4, sets the maximum pool size to 4. The thread pool can grow up to 4 threads if the core pool size is insufficient to handle the workload. Executor.set queue capacity, 500, Sets the queue capacity to 500. When all threads in the pool are busy, new tasks are added to this queue. If the queue is full, the behavior depends on the rejected execution handler. By default, it throws a task rejected exception. *executor.set thread name prefix, async thread dash, sets a prefix for the names of the threads created by the pool. This makes it easier to identify threads created by this executor in logs and debugging. *executor.initialize, initializes the thread pool executor. This is important and should be called after setting the properties. 7. Running the application, with custom threadpool task executor. Restart your Spring Boot application and access the /start task endpoint again. Observation, with custom threadpool task executor. Check your logs. You should now see thread names with the async thread dash prefix. The asynchronous task is now running in a thread named async thread1, confirming that your custom threadpool task executor is being used. 8. Understanding key threadpool task executor properties in detail. Core pool size *. This is the minimum number of threads that will be kept alive in the pool, even when they are idle. Setting a suitable core pool size ensures that there are always threads ready to handle incoming tasks without the overhead of creating new threads frequently. Max pool size *. This is the maximum number of threads that the pool can grow to. When all core threads are busy, and the queue is full, the thread pool will create new threads until it reaches max pool size. If the workload exceeds max pool size, the tasks will be rejected based on the rejected execution handler. Queue capacity *. This determines the size of the queue used to hold pending tasks. When all threads in the core pool are busy, new tasks are added to this queue. A large queue capacity can buffer a large influx of tasks, but it can also lead to increased latency if tasks spend a long time waiting in the queue. A small queue capacity will result in faster rejection of tasks when the thread pool is overloaded, which can be desirable in some scenarios. Thread name prefix *. This sets a prefix for the names of the threads created by the pool. It is extremely useful for debugging and monitoring purposes, making it easier to identify threads belonging to this specific thread pool task executor in logs, thread dumps, and profiling tools. It is highly recommended to set a descriptive thread name prefix. 9. Exception handling in asynchronous methods ***. Exception handling in asynchronous methods requires special consideration because exceptions thrown within an @async method won't automatically propagate back to the caller. Spring provides mechanisms to handle these exceptions. Option 1, using async uncaught exception handler. This is the preferred method for global exception handling. Create a class that implements async uncaught exception handler. Configure the exception handler in your async config.java by implementing async configurer. Modify async service.java to throw an exception. Update your controller. Now, when the perform async task method throws an exception, the custom async exception handler will catch it and log the error. The controller method will not be affected. Explanation ***. Implementing async configurer allows you to customize the executor and the async uncaught exception handler used by Spring's asynchronous infrastructure. The getAsync executor method returns the threadpool task executor being reconfigured. The getAsync uncaught exception handler method returns an instance of your custom exception handler. Key considerations for threadpool task executor configuration ***. Core pool size, max pool size, and queue capacity ***. The optimal values for these parameters depend heavily on the nature of your asynchronous tasks and the expected workload. Experimentation and monitoring are crucial. Asterisk CPU bound tasks. Asterisk if your tasks are primarily CPU bound, example complex calculations, a smaller core pool size and max pool size, close to the number of CPU cores, might be sufficient. A larger thread pool won't necessarily improve performance and could even lead to increased context switching overhead. Asterisk I/O bound tasks. Asterisk if your tasks are primarily I/O bound, example network requests, database queries, a larger max pool size might be beneficial, as threads will spend a significant portion of their time waiting for I/O operations to complete. Asterisk queue capacity. Asterisk a smaller queue capacity will quickly reject tasks when the thread pool is overwhelmed. A large queue can buffer incoming tasks, but it can also introduce latency. A good starting point is often to have a queue capacity greater than the core pool size. Asterisk rejected execution handler. Asterisk this interface allows you to customize the behavior when a task is rejected by the threadpooltaskexecutor, example when the queue is full and the maximum pool size has been reached. Spring provides several built-in implementations, such as asterisk abort policy, default, throws a task rejected exception. Asterisk caller runs policy, executes the rejected task in the thread that submitted it, the calling thread. This can help to slow down the rate of task submission. Asterisk discard policy, silently discards the rejected task. Asterisk discard oldest policy, discards the oldest unhandled task in the queue and then tries to execute the current task. You can set the rejected execution handler using the setRejectedExecutionHandler method on the threadpooltaskexecutor. Asterisk monitoring. Asterisk monitor the performance of your threadpooltaskexecutor using metrics such as asterisk number of active threads, asterisk the number of threads currently executing tasks, asterisk queue size, asterisk the number of tasks waiting in the queue, asterisk tasks completed, asterisk the total number of tasks completed by the executor, asterisk tasks rejected, asterisk the number of tasks rejected by the executor. Spring Boot Actuator provides endpoints that expose these metrics, allowing you to gain insights into the performance of your thread pool and adjust its configuration accordingly. Code summary asterisk. Here's a consolidated code listing for all the classes we created. Async demo application.java asterisk. Async service.java asterisk. Async controller.java asterisk. Async config.java asterisk. Custom async exception handler.java asterisk. Conclusion of part 1 asterisk. In this first part of the tutorial, we've covered the fundamental aspects of asynchronous processing in Spring Boot using the @async annotation and threadpooltaskexecutor. You've learned how to enable asynchronous processing, create asynchronous methods, configure a threadpooltaskexecutor bean, and handle exceptions thrown by asynchronous methods. You should now be able to create simple asynchronous tasks in your Spring Boot applications. Next steps, Part 2. In the next part of this tutorial, we will explore customizing the default task executor without implementing async configurer, using listenable future for handling the results of asynchronous tasks, error handling and retries, using custom executor beans for different tasks, integration testing of asynchronous methods. This foundation is essential for building more complex and efficient asynchronous systems in your Spring Boot applications.